Today we're demonstrating the extraordinary sensitivity of our ALT021 TMR magnetometers using pendulums. We set an evaluation board powered by a AAA battery next to a Newton's cradle. The sensor is sensitive enough to detect the stray magnetic field from the steel balls. This is at 5 millivolts per division, 2 millivolts per division, and 1 millivolt, or about 0.3 microtesla per division. We can still detect a signal when the balls are barely moving and the amplitude is less than 100 nanotesla. Here's a closer look at the sensor evaluation board. It has a sensor plus a simple differential amplifier. We can detect a small magnet even farther away. Here we replace the steel balls with a spherical neodymium magnet. A tray of water damps the motion so we can see what happens when the amplitude decreases. Without the water, this demonstration would take a long time. The magnet is up to a foot away from the sensor. As you can see, there's still a clear signal with the magnet barely moving. The amplifier has a gain of 5 for a sensitivity of 2.5 volts per volt per millitesla. It uses a single op-amp. The board can be powered by a 1.5 volt battery. We added an RC low-pass filter between the board and the oscilloscope. The sensor is extremely sensitive even without amplification, and can detect fields as small as 0.1 microtesla. It comes in a small package and has a high device resistance to draw just 75 microamps at 1.5 volts. Use this QR code for more information.